So consider this diagram now. In this case, what I have is I have two lines. Line X is parallel to line Y, okay? And let me put some arrows here so that it looks like a line, okay? And then we have a line M, and this line M intersects these two parallel lines. Okay, in such condition, when there is one line that intersects two parallel lines, or maybe two other lines, they don't have to be parallel, okay? Such line is called a transversal line, all right? That is the name for the line M in this case. But in this case, we are taking the two lines X and Y to be parallel. Now, when we come across this kind of diagram, we need to define few more terms here. So let me start with putting the names of various angles that are happening as a result of this intersection. So we will start with 1, 2, then there is 3, 4. These are the names of the angles, okay? And then there is 5, 6, 7, and 8. So first we define there are some interior angles in this case. Interior angles are the ones that are between the boundary of X and Y, because consider it like this, that they are inside some region, they are inside some boundary, hence we reserving a name for them as interior angles, okay? So interior angles are 3, 4, and 5 and 6. If this is the interior, then that suggests me that anything which is outside the boundary of X and Y, or below Y and above X, these angles are called exterior angles, all right? So my exterior angles will happen to be 7, 8, 1 and 2. 1 and 2 are coming from here, okay? And the one important property you need to know with this arrangement is a term called corresponding angles. What are corresponding angles? If you look at angle 2 and angle 6, they are corresponding angles. And we say that corresponding angles are equal. What other corresponding angles you see in this arrangement? I will say that angle 1 and angle 5, they are also equal and they are corresponding angles. I will also say that angle 4 and angle 8, they are also corresponding angles. Hence, we can say that they are equal. The necessary condition in corresponding angles is that the line M, which intersects two lines, those two lines, in this case X and Y, they have to be parallel. If they are not parallel, then you cannot state this property, okay? Now, this is very critical to understand. Once you know this, and with the property of vertically opposite angles, you can figure out any other arrangement of angles, okay? So let me define one more important property, and that is about alternate interior angles. What is that? We know that 3, 4, 5, 6, 4 of them, they make interior angles. The angle 3 and angle 5, that makes a pair of alternate interior angles, because simply think of it this way. Angle 3 is formed between M and X, right? And it is on left hand side to M. And angle 5 is formed by M and Y, and it is on the right hand side of M. Hence, it is called alternate interior angles, and they are equal to each other. All right. Likewise, the other pair of alternate interior angles would be angle 4 and angle 6, and I will say that they are also equal. So these are two critical properties that come up as an arrangement of two parallel lines being intersected with a transversal line. So keeping this in mind, I would like to list down what angles are equal to each other, and you will find it surprisingly simple that how many angles in this arrangement could be equal to each other. So starting with the corresponding angle property, we will say that angle 2 is equal to angle 6, right? Just from here, correct? If you only focus on the intersection of M and X, you know that angle 2 is equal to angle 4, correct? That is by the knowledge of vertically opposite angles by the intersection of two lines, correct? 2 is equal to 4 and 2 is also equal to 6. That means they all got to be equal to each other, because otherwise the relation won't hold. And at the same time, now let me look at the second arrangement in which I say that angle 1 is equal to angle 3 because of vertically opposite, right? And angle 1 is a corresponding to angle 5, right? If I look at the entire picture, correct? So 1 is equal to 5 and 1 is also equal to 3. That means 1 and 3 and 5 are equal. Straightforward, correct? Nothing very complicated. Now, if I look at the arrangement of line M and line Y, I see that 5 is equal to 7 simply because of what? Vertically opposite, right? So I can put one more equivalency here. This is equal to 7. At the same time, there is only angle 8 left. 8 is equal to 6. Why? Vertically opposite. 6 is equal to 8, right? But 6 is also equal to 2 and 6 is also equal to 4. So we will say that this is equal to 8 right here. So these four angles are equal. These four angles are equal. Now this will help you understand the moment you are given one angle in this entire arrangement, you can figure out the rest of the story from here. Alright, take a look at this problem. There are only two things given to us, line B and line C. They are parallel to each other and the line A is an intersecting line. So line A is transversal, correct? And the angle formed between the intersection of line A and line B, the angle 1, it is equal to 40 degree. Alright. Everything else we are supposed to find, meaning find all angles that you see in this diagram. What are their values? Alright. Given angle 1 is 40 degree, we can say that angle 2 is equal to 180 degree minus angle 1 because two angles on a line, they make 180 degree, correct? So that means angle 2 is equal to 180 minus 40 is equal to 140 degree. From here, it should be a matter of few seconds only. So angle 1 is equal to angle 3 because vertically opposite angles, right? So angle 1 is equal to angle 3, correct? And we know that angle 1 is already 40 degree, correct? Then the line C is parallel to line B. That means 6 is equal to 3 because alternate interior angles are equal, right? 3 and 6 are alternate interiors, right? That means 3 is also equal to 6. Okay, now come back to the intersection of line A with line C. 6 should be equal to 7. These are vertically opposite angles. Okay, so we got four angles resolved right now. 1, 3, 6, 7. All of them are equal to 40. Okay, now angle 2, we know that it is equal to 140 degree, right? So angle 2 is equal to what? Angle 4, vertically opposite, right? Simple enough. Angle 4 is equal to angle 5 because these two angles are alternate interior angles. And angle 5 is equal to angle 8, correct? Because of what? Because they are vertically opposite angles. And there you go. There is your result. So this is the application of your knowledge on alternate interior angles or vertically opposite angles or corresponding angles.